This is a presentation over Light and Matter by Mallory Snyder and Yutong Lee.
Firstly, light is a form of electromagnetic radiation with wave-particle duality, which means light has the properties of both wave and particle. Light wave is a vibration of electric and magnetic fields.
The particles of light are called photons, named by Gilbert N. Lewis in 1926. Each one has a wavelength and a frequency. The energy of photons depends on its frequency. The equation to show this is energy equals H times F. H is the constant of nature called Planck's constant. The basic properties of waves are wavelengths and frequency. Wavelength is the distance between the two wave peaks, and frequency is the number of times per second that a wave vibrates up and down. More importantly, light waves have magnetic fields and electric fields. They're perpendicular with each other, and both of them are perpendicular with the radiation direction.
The visible light we can see all the time is only a small part of light. Regarding the wavelengths from shortest to longest, light include gamma ray, X-ray, ultraviolet, visible light, infrared, microwave, and radio wave.
There are 4 ways in which light can interact with matter. Emission is the first one, which is where matter releases energy as light, such as the sun. The second one is absorption, where matter takes energy from light. The third one is transmission, where matter allows light to pass through. And the fourth one is reflection, where matter repels light in another direction, such as when you look in a mirror.
Structure of matter. Matter is made of atoms, which consist of a nucleus of protons and neutrons, surrounded by a cloud of electrons. Atomic number equals number of protons in nucleus. Atomic mass number is number of protons plus neutrons.
As energy increases, molecules change from phases of matter. When they're solid, the molecules are arranged in regular repeating patterns, held firmly in place, but they can vibrate within a limited area. At liquid, they flow easily around one another. They're kept from flying apart by attractive forces between them. At gas, the molecules fly in all directions at great speeds. They're so far apart that the attractive forces are insignificant. At plasma, very high temperatures of stars, atoms lose their electrons. The mixture of electrons and nuclei that results in this is plasma in this state of matter.
There are 3 basic types of spectra. Continuous spectrum. The spectrum of a common light bulb spans all visible wavelengths without interruption. Emission line spectrum. A thin or low-density cloud of glass emits light only a specific wavelength that depend on its composition and temperature. Absorption line spectrum. A cloud of gas between us and a light bulb can absorb light-specific wavelengths, leaving dark absorption line in the spectrum.
Biosensors measure the change in how a molecule reacts to light due to its surrounding environment. Using this, they use tiny gold particles called nanoparticles to see cancer cells that normally wouldn't be able to be seen in tissue. Here, the nanoparticles bind to the cancer cells and increase the amount of light reflected from the cells.